Hello and welcome to another episode of How to Do That. Today we are going to be discussing resistors, and this is the first in a components series that will explain what each of the components' purpose is, how it works, things like that, just so you have at least a better understanding when you're working with circuits why the components are where they are and how to design with them. So here I have a resistor, and we're not going to talk about the color codes. I have another video for that called Resistor Color Codes on the channel if you would like to look at that. But I do want to discuss how a resistor works and why it is even important. So the first thing to note about this resistor is its size. It's quite a small body. This is the body of the resistor, and you have two leads or two wires coming out from either end. Now, this little body here is actually what does all the work. The wires are simply to hook it up. Now, unlike a diode or an LED, something like that, where current can only flow in one direction, a resistor doesn't care. I'm sure there's probably some exception out there, but for basically all the cases you'll encounter, a resistor does not matter if the electrical flow goes through one side or if it goes through the other. It will work all the same. Now, a resistor is a passive element. What that means is that there is no power added to it in order for it to work. So as long as it is hooked in your circuit, there's no reason to power it per se. I mean, it's going to dissipate power because that's its job, but there's nothing needed to power it, unlike something such as a transistor, which requires a voltage to tell it to do something. So this is a passive component. The whole purpose of a resistor is to reduce the current flow. It could also be used to divide voltages. This right here is actually a fixed resistor. No one really calls them that. They just say resistor if they mean this type of resistor. It just means that it has a fixed singular value. It's only ever going to have one resistance value, and that is dictated by what the bands are here. So in this case, I want to say this is a 220 ohm resistor. Nothing that we do, no amount of current that we put through it, no matter what voltage it is going to change that value. It is always going to be a 220 ohm resistor. They do make variable resistors to where you can say like turn a knob and it will change the resistance going through the circuit. An example of that is something like a volume control on a radio, or even a light dimming knob that you might see in like a living room or something. So there are resistors all around us. Now, the way that a resistor will actually work is that inside of this body, at least with most modern day resistors, you have some type of carbon or metal film that, while it is conductive, is highly resistive. So it doesn't want to allow electricity to flow through it. And this can be done with material selection. Maybe the material is just resistant to electrical flow, or perhaps the material inside is just extremely thin. Think of like a light bulb, how thin that filament is inside of an incandescent light bulb. There's a similar principle at play inside of resistors where you have a very, very thin coil of wire that's creating a lot of resistance. But again, most modern day resistors use some type of, carbon or metal film to do the same thing. No matter which way you do it, the job of the resistor is to resist the electrical flow, and it dissipates that power in the body as heat, and therefore not allow that electrical flow to continue on and hurt any other type of component that may be before or after it. So I've done a lot of explaining as to what a resistor is, but I haven't told you why, in a fundamental sense, why you need a resistor. Why can't we just hook wires up to, positive and negative on something and run power through it? Well, to show you that, we're gonna have to do a little bit of math. So why is a resistor important and why should we care? Well, let's look at a circuit without a resistor in it first to know the answer. So first I'm going to draw a battery here, and we're going to connect it up to, let's say, an LED, and complete the circuit. Okay, so we have a battery powering an LED. Now let's say that this battery is a 5-volt battery. Using Ohm's law, we know that current equals voltage divided by resistance. Now, everything has resistance. These wires have a resistance. This LED itself has resistance. And typically for smaller hobbyist projects, you can ignore usually the resistance in the wires because everything else has so much greater resistance that the resistance in these wires is negligible. So I am also going to be ignoring that in this example. But we have this LED here, which has a little bit of resistance, a very, very small one. Let's just put a number to it and say that the resistance in ohms of that LED is approximately 0.001 ohms. Just to put a number to it, I actually don't know what a resistance of a regular LED is. Now, you're not gonna have to worry in your projects what the resistance of an LED is. I'm just using this as an example to show why we need resistors. So this 0.001 ohms, we're going to put in our equation here. So we have 5 volts and we have 0.001 ohms as our resistance. So that's going to equal 5,000 amps. Now, you may not be aware of this, but that is a ridiculous amount of amperage. That 5,000 amps is obviously a bad thing. But that's only going to last for a split second because this LED will immediately burn out. And that will then open the circuit back up to where power will not flow anymore. And that's generally what happens in a situation like this, is if you have too high of an amperage, one small component will burn out, and then that opens the circuit so there's no more electrical flow. Electricity stops. So then the 5,000 amps goes to 0 amps the moment that the LED burns out. So how do we prevent that? And this is just 5 volts, and yet we drew that many amps. Let's ignore that these wires wouldn't actually support that amps. I'm just using this as an example. So what do we do about this problem? How can we make it to where an LED can run off of the 5 volts that we are supplying? Well, we need to control the amount of electrical flow that will go to our LED. And the way we do that is with a resistor. So the resistor will allow us to bring down this current over here into a more manageable level. So on the data sheet for this LED, let's say that it's able to take, let's see, LED current maximum continuous. And continuous, by the way, just means that you can use it basically infinitely at that current, which is what you always want to make your circuits based upon. So that LED max continuous current on the data sheet, let's say it is 50 milliamps or 0.050 amps. So we want to make sure that we bring down the amperage in this circuit enough to where the amount of amps going through this LED is at most 0.050 amps. Now the way we do that is with the resistor. So now I'm going to draw the same circuit again, but this time I'm going to use a resistor. And if you don't know what a data sheet is, it's something that's supplied with the LED when you purchase it. So it might be on the back of the box, it might be a piece of paper inside, but it's just a table of values that's basically, hey, don't go above these limits. And this will be one of those values. We have our circuit here again, still the same 5 volt power supply, but now we're gonna put a resistor in the circuit, but we don't know how big of one that we need. We do know that a resistor will decrease the current, and we know that we want that. So we know we at least need a resistor in the circuit, but we don't know what size of resistor in the circuit. Now, we could go ahead and calculate, what's the resistance of this LED? But I'll go ahead and tell you that most of the time your resistance values are going to be, at least 1 ohm. So at least 1,000 times the resistance of this LED. And just like before when I said that even though technically wires have a resistance, we generally ignore that, I'm going to do the same thing now with this LED because this resistance value is going to be so much higher than the LED that it's really not going to make a difference to use this in my calculation. It's just going to overcomplicate things. Okay, so let's calculate what this resistance value needs to be to make sure that this LED stays alive. So we're going to go back to Ohm's law actually. So I equals V over R. But we're wanting to solve for R. We actually have I, it's right here. We have V, it's 5 volts. We need to solve for R. So let's rearrange this equation and solve for R. So that means R equals V over I. We're now ready to solve for what that resistor needs to be. So R equals 5 volts divided by the maximum continuous current given by the data sheet on the LED, which is 0.050 amps. And this does need to be in amps. It can't be in like milliamps or something. So always convert to amps. And that value is 100 ohms. So now we know that if we select a 100 ohm resistor and put into this circuit, that this LED will only have 0.05 amps running through it, which means it will last for as long as its life is rated for. So that is the purpose of a resistor in a circuit. Now, you may be wondering, did I, on purpose, put the resistor between the positive terminal and the LED? And the answer is, it doesn't matter too much. Now, when you're programming microprocessors, you have things like pull up and pull down resistors, and that's more advanced and for another video. It's not really necessary to know for why do you need a resistor. But a resistor, I could have put it up here, or I could have even put it here if I wanted to instead, to where it'd be on the other side of the LED. But how does that make any sense? Because you have the power coming from the battery, and if there were no resistor here, it would just go straight on through, bam, gonna hit my LED before it even gets to the resistor. So why is it that that would still be okay to do? Think of electrical flow like a water pipe system. If I have pipes, okay, and you know, let's say that this is my pipe. I have my flow of water flowing through it, and that pipe never constricts or anything. It just stays like this. I know that forever my flow is going to be the same throughout. Okay. Now, what happens if on down the line here I neck it down and then even come back up? Well, this neck down right here is going to cause a restriction in the flow. Just after it? No, on the whole pipe system, because whatever water is flowing in has to flow out. So no matter where I put this constriction, it's going to affect the downstream water and it's going to affect the upstream water because it all has to go through here. It's going to restrict that flow. Likewise, a resistor you can think of as restricting flow. So it doesn't matter where I put the resistor, I'm going to be slowing down the entire flow both before it and after it simply because there is a restriction in the flow. So to sum up, you need a resistor, at least one, in every circuit, just as a general rule, in every circuit that you make. And a circuit is any loop in which electrical current can flow. So typically, you know, you're gonna have some type of positive side of, say, a battery, and that loops around connecting all these components and then ends in the negative side or a ground. And that is one complete circuit. It goes from a positive all the way down to a negative. So you always need at least one resistor for every circuit that you make. And furthermore, even though this is getting into some more advanced concepts, just know that in a single circuit such as this, the current, this flow, is the same throughout that entire circuit. So just like with the water pipe example, that flow is the same up here as it is down here. Same thing with a circuit. Current here is the same as current here, is the same as current here, is the same as current here throughout. And that is also why you can just use a single resistor. No matter how many items are on your circuit, you can have just one resistor that can actually help control the current for all of them. And if you had more than one LED, you would want to use the LED with the smallest current maximum value, just because if you use, say, the one with the largest value, you would actually burn out the one with the lowest value potentially. So you always want to use your limiting factor for what current you use in the Ohm's law equation here. So that pretty much covers resistors, but I do want to cover one more thing, and that is, obviously there is a bit of a cost to using a resistor, and that cost is in the form of energy. Now, you can calculate the power dissipation in watts that a resistor will be pulling from the system and losing in the form of heat. And we can do that very easily. Let's use our previous example here. We know that the current going through the entire circuit is 0.050 amps. We also know the size of the resistor that we're now using, which is 100 ohms. And by the way, you would probably want to increase this resistance value, say to the 150, 200 ohms, just to give yourself a little bit of a buffer, because whenever you first turn a circuit on, in case you didn't know, there is a little bit of a jump in current when things first get started. So if you want to kind of insulate yourself from that, you'd realistically want to pick a slightly larger value of resistor. Our resistor that we chose is 100 ohms. Now, to calculate the power in watts that is going to be dissipated from a resistor, it's actually a really simple equation. The power that you're going to lose is equal to the current squared times R. We have both of those values. Power equals 0.050 amps squared times 100 ohms. And that equals 0.25 watts. And that is how much power will be dissipated by the resistor in the form of heat. So whatever power you're expecting in your circuit, which for a small resistor like this doesn't really matter for a 100 ohm resistor, but in other circuits, if you use a really large resistor, you will actually need to care about how much power is being dissipated by the resistor, because your components also in the circuit may be expecting a certain wattage. If you can't supply that wattage, you may have unexpected behavior. So it's just something to keep in mind, that is how you calculate the amount of power dissipated by your resistor. I hope that let you see what a resistor is, why it's important, when you need one, which is basically all the time in a circuit. And if you have any more questions, please comment down below. Please hit the thumbs up button on this video and subscribe. It is free. It really does help out the channel. And if you have any other ideas for which components you'd like to see me do a video on next, or if you'd like more information on a resistor, please comment down below. I do read the comments. So until next time, see ya.